Hello, my wonderful people. Welcome once again to another Mathematics Olympiad class. We have 3 questions to be considered. So we go for the first one. The first question here is on imaginary number, and is we are to simplify I raised to power 40. That is, for us to simplify this I raised to power 40, we need to first break down the I raised to power 40 to I raised to power 2. That is, how many I raised to power 2 using the law of exponent can we use multiply together and then solve it using the law of exponent that will give us I raised to power 40. That is I raised to power 2 in 20 places if we multiply them together. If we simplify it using the law of exponent, that is, if we take one of the bases, that is the high, because they have the same base throughout, then we add all the powers together according to the law of exponent or law of indices. We have I raised to power 2 plus 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 2. By the time you add all the 2 in 20 places together, you get 40. It will now become I raised to power 40. That is, I raised to power 2 multiplied together in 20 places using the law of exponent to simplify it, we give us I raised to power 40. So now we are using that to simplify I raised to power 40. So I raised to power 2 in 20 places now multiplied together will give us I raised to power 40. Then since I raised to power 2 is minus 1, it means we can multiply minus 1 in 20 places together. So if you multiply minus 1 in 20 places together, it will give us 1. That is, all the minus, multiply them together. Minus times minus plus, plus times minus, minus, minus times minus plus, plus times minus, minus. If you multiply like that to the last minus, the last minus there, you get plus. Then if you multiply all the ones, you get 1. Then it means I raised to power 40 will give us 1. Positive 1. Now we have the second question. The second question also is on imaginary number, but it has to do with expansion of brackets. So we have 5 into bracket 2 minus I minus 3 into bracket 4 plus 2I. Now to expand the bracket, we use the 5 there to expand the first bracket and the minus 3 to expand the second bracket. So the first bracket we have 5 times 2, 10, plus times minus is minus, then 5 times I, 5I. Then the second bracket, minus times plus, there is a plus sign in front of 4 there. So minus times plus is minus, 3 times 4 is 12. Then minus times the plus in front of 2I, minus times plus is minus also, 3 times 2I, 6I. So if you collect the like terms, we have 10 minus 12 minus 5I minus 6I. 10 minus 12 will give us minus 2. Then minus 5I minus 6I will give us minus 11I. So we have minus 2 minus 11I. That's number 2. Now we have the third question, question number 3. And the question is not on imaginary number. So this one is kind of exponential question. Now we have 2 raised to power x plus 3 raised to power x minus 4 raised to power x plus 6 raised to power x minus 9 raised to power x equals 1. We have to simplify and find the value of x. Now to find x here, the first thing we have to do, we are going to break down 4. That 4 raised to power x, we break it down to 2 times 2. We break down 6 to 2 times 3, and we break down 9 to 3 times 3. So we have 2 raised to power x plus 3 raised to power x minus open bracket 2 times 2 raised to power x plus 2 times 3 into bracket raised to power x minus 3 times 3 into bracket raised to power x equals 1. Then we have 2 raised to power x plus 3 raised to power x minus 2 raised to power 2x, that is 2 times 2 is 2 raised to power 2. That is 2 in 2 places. Then since it's having power x before, we now have 2 raised to power 2x. Then plus, we open the bracket of 2 times 3 raised to power x. So we give the x power to the two of them. So we have 2 raised to power x times 3 raised to power x, then minus 3 in 2 places. That is 3 raised to power 2, then raised to power x equals 1. That is, we have 2 raised to power x plus 3 raised to power x minus 2 raised to power 2x plus 2 raised to power x times 3 raised to power x minus 3 raised to power 2 into bracket raised to power x equals 1. So here we have 2 raised to power x plus 3 raised to power x minus 2 into bracket 2 raised to power x into bracket raised to power 2. That is, we have separated the two powers, 2 and x. We bring the 2 out, then the x inside the bracket. The 2 are still powers on 2. So we have minus 2 raised to power x into bracket raised to power 2 plus 2 raised to power x plus 3 raised to power x minus 3 raised to power x into bracket 2 power 2 equals 1. Why we are doing it is we want to bring out 2 raised to power x and 3 raised to power x and represent them with letters. So we are going to represent or plug in 2 raised to power x as f and plug in 3 raised to power x as g. Now, if you do that, we have 2 raised to power x there will be f plus 3 raised to power x there will be g minus f raised to power 2 plus f times g minus g squared equals 1. So now we can minus 1 from both sides. So we have f plus g minus f squared plus fg. F times g is fg. Then minus g squared minus 1 equals 0. So the next step is we multiply through by minus 1. So if we multiply through by minus 1, we have minus 1 times plus f will give us minus f, minus 1 times plus g will give us minus g, minus 1 times minus f squared will give us plus f squared, minus 1 times plus fg will give us minus fg, minus 1 times minus g squared will give us plus g squared. Minus 1 times minus 1 will give us plus 1. So we have minus f minus g plus f squared minus fg plus g squared plus 1 equals 0. So the next step again, we multiply 2 by 2. So if we multiply 2 by 2, we have minus 2f minus 2g plus 2f squared minus 2fg plus 2g squared plus 2 equals 0. That is 2 times minus f minus 2f, 2 times minus g minus 2g, 2 times f squared plus f squared, that's plus 2f squared, 2 times minus fg, that's minus 2fg, 2 times plus g squared, that's plus 2g squared, 2 times plus 1, that's plus 2, then equals 0. Now the next step here is since we have minus 2f minus 2g plus 2f squared minus 2fg plus 2g squared plus 2 equals 0, we collect the like terms. So we have 2f squared, those ones that are having the same squared, the same exponent together. 2f squared plus 2g squared, they have squared as their exponent. Then minus 2fg minus 2f, they have, then minus 2g, they all have 1 as their exponent. Then plus 2 equals 0. That is 2f squared plus 2g squared minus 2fg minus 2f minus 2g plus 2 equals 0. Then if you rearrange everything, or we split the 2f squared to f squared plus f squared, because f squared, 1f squared plus 1f squared means 2f squared. So if you split it or simplify it, break it down, we have f squared plus f squared, that will give us 2f squared, then plus 2g, g squared plus g squared, that will also give us 2g squared, then minus 2fg minus 2f minus 2g plus 1 plus 1 plus 1 plus 1 will give us plus 2, then equals 0. That is, after simplify 2f squared plus 2g squared minus 2fg minus 2f minus 2g plus 2 equals 0, we have f squared plus g squared plus g squared minus 2fg minus 2f minus 2g plus 1 equals 0. Now, if we then f squared plus g squared minus 2gf, that is, we are rearranging now, f squared plus g squared minus 2gf plus f squared minus 2f plus 1 plus g squared minus 2g plus 1. We are rearranging all the letters, all the values here, because we want to bring out something, we want to make sure it can be easily simplified now, and that's why we are rearranging. We take the first f squared, we now add plus g squared, one of the g squared, g squared, then minus 2fg, we put that one aside as one equation. Then we take the second f squared plus f squared, then minus 2f, then plus 1, that one aside as one equation as well. Then we now take the plus g squared, the second g squared, minus 2g plus 1, the last one there, then that one also has one equation. So there, the way we have arranged everything, we have arranged them in a kind of 3 equations. The first one is f squared plus g squared minus 2gf, one equation like that. F squared minus 2f plus 1, another equation there. G squared minus 2g plus 1, another equation there. Now, since we have f squared plus g squared minus 2gf, the first equation there, then f squared minus 2f plus 1, the second equation there, then g squared minus 2g plus 1, the third equation there. Then by factorization, if you factorize f squared plus g squared minus 2gf, if you factorize that, it will give us f minus g into bracket squared. That is, if you expand f minus g into bracket squared, it will give us f squared plus g squared minus 2gf. Then if we factorize by factorization, if we factorize f squared minus 2f plus 1, it will give us f minus 1 into bracket squared. That is, if you factorize f minus 1 into bracket squared, it will give us f squared minus 2f plus 1. Then the third equation now, g squared minus 2g plus 1. If you factorize it, we get g minus 1 into bracket squared. That is, if you expand or expatiate, simplify g minus 1 squared, it will give us g minus 1 into bracket times g minus 1 into another bracket. If you expand it and solve it, you will get g squared minus 2g plus 1. So if you use f minus 1 squared now, then if we expand it, we have f minus 1 into bracket multiplied by another f minus 1 into bracket, and we equate it to 0. Then we take the first f minus 1 equals 0. Then we plus 1 to both sides, then we have f equals 1, or take minus 1 to the other side, then f equals 1. If we do the same thing to g minus 1 squared into g minus 1 into bracket squared, we have g minus 1 into bracket, g minus 1 into bracket equals 0. Then we take g minus 1 equals 0, plus 1 to both sides, or take minus 1 to the other side, we have g equals 1. So meaning that f is 1 and g also is 1. So since 2 raised to power x equals f and f equals 1, then we can just plug in the values. If you remember, when we started solving, we say we should plug in 2 raised to power x as f. Now our f is 1. It means we can replace 2 raised to power x as 1, or equate it to 1. So we have 2 raised to power x equals 1. Now, since 2 raised to power 0 is equal to 1, in order for them to have the same base, so we have 2 raised to power x equals 2 raised to power 0. That 2 raised to power 0 is still 1 there. So, since they have the same base now, we can cancel out this base and then x and equate the power. Then we have x equals 0. Likewise, 3 raised to power x rather equals g. We said that when we started solving that we should plug in 3 raised to power x as g. Now, since g equals 1, then it means 3 raised to power x equals 1. Now, since 3 raised to power 0 is 1, it then follows that 3 raised to power x equals 3 raised to power 0, because 3 raised to power 0 there is still 1. Then since the base are the same now, we can cancel out the base, then equate the powers, then we have x equals 0. Now, our exercise for the next class will be simplify open bracket 5 over 2 close bracket all raised to power 2 over 5. So to meet next class, don't forget to click subscription, notification, like button, and to share the video with your friends. Thank you.